Hi everyone, welcome back to my Calculus 1 series. Today we are tackling a fascinating topic, the derivatives of inverse trig functions. Functions like arcsin, arccos, and arctan may seem a bit abstract, but their derivatives are incredibly useful in solving real-world problems and more advanced calculus questions. In this video, I will walk you through the derivations and key formulas, followed by some practical examples to solidify your understanding. Let us get started. Now, for inverse trig functions, you have to know six of them. So the first one has got to do with arcsin. Let me use a different color. Now, if you differentiate arcsin of x, you end up getting 1 minus x squared. Then the next has to do with arctan. Remember, arcsine, arctan, arccos is the same as tan inverse, sine inverse of x. They are the same, right? So you can write arctan or tan inverse. It all means the same thing. So if you differentiate arctan, you have 1 over 1 plus x squared. The next one we have to look at is arcsic. And if you differentiate, this is always 1 over the absolute of x, then x squared minus 1. Now, you don't need to memorize these things, right? If you know these three, you are good to go. Now, you just have to relate these things on the left hand side to the one I'm going to write now. Now, arcsine always goes with arccosine. So if we differentiate, all that you have to do is to negate arcsine. So in this case, you have negative 1 out of the square root of 1 minus x squared. Tangent, arctangent always goes with arccotangent. So in this case, you have arccot of x. You just have to negate the tangent. So you just have this. And the last one has got to do with arccosecant. So in this case, we have negative 1 over the absolute of x, then x squared minus 1. So these are the 6 basic properties that you have to know, right? These are the inverse trig functions that we have. Now we are going to use this idea to solve questions. So let's look at the first one. We have to use reference triangles to find the angles in A. We have to find what is arctan of 1. B, we have to find arctan of 1 over root 3. Let me write this well. And C is tan inverse of negative root 3. One thing that you have to note, the reference triangles that we are talking about, it's easy. So you have this. Okay, so this angle right here is always 90 degrees. This is always 60 degrees, and this is 30 degrees angle. This side, using the Pythagoras theorem, this side is 1, side is 2, and this side is root 3. This side is 90, as always. This is 45, and this is a 45 degrees. This side is root 2, this side is 1, this side is 1. This is just to help you find any angle that you are being given. So these are what we call the reference angles. So yeah, you should know this, right? So now when we are told to find, the first question is find arctan of 1. Now arctan of 1 basically means, let me write it here. Find arctan of 1. What is it equal to? It basically means what is tan x equal to 1. What value of tangent will give you 1? So we use these reference angles, right? Now looking at the first triangle that we have over here, in writing them in a fraction form, you see that you have 1 over 2, 1 over root 3 over 2. Basically, what I'm trying to say is there is no value over here that will make or give you 1, right? It's always going to be 2 over root 3, 1 over root 3, root 3 over 1 whatsoever. And you can't have 1 over 1. So in this case, we move on to the second one. In the second triangle over here, there's a possibility that you can get this 1 out of 1 or this 1 out of 1, right? And remember, tangent, we are using the SOHCAHTOA. Tangent is opposite over hypotenuse. So in this case, if we use this 45 reference angle, opposite of 45 is 1, and the adjacent is also 1. If we use this 45 angle, the opposite is 1 here, the adjacent is 1. So basically what it means is that when we have tan of 45 degrees, that is when we have 1 out of 1, which is 1, which is this. You understand? So it means the x value that we are interested in finding is 45 degrees. So our x is equal to 45 degrees, or we can have it as pi over 4. So arctan of 1 is pi over 4 or 45 degrees. I hope this is clear. Now let's look at the second one. The second one is arctan of 1 over 3. Now using the same analogy, when we come over here for the second triangle, we don't even see any root 3, so we can't use the 45 reference angle. We have to come over here. There is a root 3 here, so we can use the first triangle, right? So what we are interested in is we want tan of x to be equal to 1 over root 3. So we have to using this angle, right? What is the tangent of 30? Remember, opposite over adjacent. So opposite is 1 right here. Adjacent is root 3. So you see, we have tangent of 30 is equal to 1 over root 3. If we select 60, opposite is root 3, adjacent is 1. So it's going to be root 3 over 1, which is not the same as what we have. So you can't use 60. So the correct answer is 30. And remember, 30 is the same as, so our x is equal to 30 degrees or pi out of 6. I hope this is clear. Now let's look at the third one. The third one is tan inverse. Remember, tan inverse is the same as arctan, right? So we want tan inverse of negative root of 3. And in this case, we want our tan of x to be equal to negative root of 3. Remember, for both triangles, we don't have any negative sign. What we have is root 3. So in this case, root 3 is not in the second triangle, it's not here, but it is in the first triangle. So to find root 3, remember, we have to use 60. 60 is what we have opposite, which is root 3, dividing the adjacent, which is just 1. So root 3 over 1, when x is equal to 60 degrees, that is when we have root 3 over 1, which is basically root 3. So we can use this. But now, the answer we are looking for is negative, not positive. So all that we have to do is to just negate the 60 degrees. So we have negative 60 degrees, or we can have it as negative pi over 3. I hope this is clear. So whenever you have it in degrees and you want to set it in radians, all that you have to do, let's say you have over here, the reason why we had pi over 4 is we can write 45 over 180, because angles in the triangle sum up to 180, right? And we multiply it by pi. Now, when we do that, 45 out of 4, this goes over here 1, this goes into this 4 times, so we just have 1 over 4 pi, which is just pi over 4. So that's how we get it in radians, if you were confused about that. Okay, let's look at another one. Let's say we have secant inverse of negative root of 2. So we do the same thing, right? So we want secant of x will give us negative root 2. Remember, secant of x is the same as 1 over cosine of x, and this is equal to negative root 2. So we can make cosine of x the subject. If we do that, we have cosine of x, and this is negative 1 out of root 2. So going back to the reference angles, we don't have root 2 over here. Root 2 is in the second triangle. So in that case, we are talking about a 45 value. Do you get me? So over here, cosine of, so it means our x, if it was positive, our x would have been 45 degrees. But now it is negative, so your x can be negative 45 degrees. Does this explain it? Do you understand it? Yeah, so this is how to solve it. Now, the next one is arc cosine of root 3 over 2. So in that case, we have cosine of x to be equal to root 3 over 2. So for root 3, we can't use this. You have to use over here. So cosine is adjacent over hypotenuse. So the adjacent over hypotenuse, which one do we use? We have to use 30 degrees, right? The adjacent of 30 is root 3, and the hypotenuse is 2 in this case. So it means that our x is just 30 degrees, or we can say pi out of 6. For f, we have to find arc cosecant of negative 2 over root 3. So in this case, all that we want to find is what value will give you this. Remember, cosecant of x is just 1 over sine of x, So this is equal to negative 2 over root 3. And if you find sine of x will just be equal to negative root 3 out of 2. So we want the value of x that will give us negative root 3 over 2. Remember, we are not going to use the second triangle because root 3 is over here and sine is opposite over hypotenuse. So the angle that we have to use is 60 degrees because the opposite is root 3, the hypotenuse is 2. So when x is equal to 60 degrees, that's when we have positive root 3 over 2. So if we want the negative, we have to use x is equal to negative 60, or in radians we can say negative pi out of 3. I hope this explains the concept, and I hope you really understood everything that we've done so far. Okay, let's move on. So the next question, which is question 2, we have to find the derivatives of y with respect to x. So over here, the first one is y equal to cos inverse of x squared. Remember, we know that if we differentiate cos inverse of x, we have negative 1 out of 1 minus x squared. So if you differentiate, the reason why we have this is always if we differentiate x, so you multiply this by 1. If you differentiate x, you get 1. 1 times negative 1 is the same as negative 1. That is why we don't write it. So in this case, if you differentiate, all that you have to do is wherever we see x, wherever we see x over here, we have to replace it with the x squared that we are given. So there is the same thing, just that we've changed x to x squared. So we just have negative 1 in the numerator. In the denominator we have 1 minus. Now we have x, we have to change it to x squared, but we have squared already, so we bring it outside. Then we differentiate what is inside the parentheses. So if we differentiate x squared, you have 2x. So this just simplifies to negative 2x, and in the denominator you have 1 minus x to the 4th. Let's look at a different question. So we have arcsin of 2x plus 1. But note, if we differentiate arcsin of x, this is just 1 over the absolute of x squared minus 1. And now, instead of x as our angle, we have 2x plus 1. So all that we have to do is to change x to 2x plus 1. So this is just going to be so this is 1 out of absolute. Now instead of x we have 2x plus 1. Instead of x squared we have 2x plus 1 squared. Then we bring the minus 1. So you can simplify this further. Note, if you have 2x plus 1 squared minus 1. This is the same as, now if we expand 2x plus 1 squared, you have 4x squared plus 4x plus 1 and minus 1. You bring the minus 1, which just simplifies to 4x squared plus 4x, which is the same as, we can factorize the 4 outside, then we have x squared plus x over here. So this is basically the same as writing root of 4 multiplying root of x squared plus x, and root of 4 is just 2, so we have x squared plus x. So if we expand this, this is what we get. Note, whenever you are differentiating, you have to multiply it by the differential. So in this case, if we differentiate what is inside 2x plus 1, you get 2, so you have to multiply it by 2. You have to multiply here by 2, and the denominator we have 2 multiplying x squared plus s. So this 2 will cancel this 2 right here. So we have our final answer to be 1 out of, we have 2x plus 1, and we have x squared plus x. Okay. Now let's look at our last question. We are to differentiate tan inverse of square root of x squared minus 1 plus inverse of x, where x is greater than 1. Okay, so let's differentiate. First of all, we differentiate both sides. So we have the dx of tan inverse of square root of x squared minus 1 plus the dx of the last term. And note, we know that the dx, if we differentiate this, we have negative 1 out of the absolute of x squared minus 1. Now differentiating tan inverse of x, this gives, remember, 1 over 1 plus x squared. So if we are differentiating, tan inverse of x squared minus 1, we have to change x to x squared root of x squared minus 1. So this is basically 1 out of 1 plus, now our x was given as x squared minus 1, and then we square it. Then we differentiate this. So now if we differentiate, let's differentiate this right here. We have x squared minus 1. How do we differentiate this? Remember, this is the same as x squared minus 1 to the exponent of 1/2. If you are differentiating using the power rule, 1/2 comes down. We have x squared minus 1. Then you subtract 1 from the exponent, so you have negative 1/2. Then you multiply it by the differential of what is inside the parenthesis, which is just 2x. Instead of using the power rule, you can also use the chain rule. So in this case, this 2 cancels out this 2. So we have to multiply everything now we've written over here by what we got over here. So we have x multiplying x squared minus 1 all to the power of negative half. So we can rewrite that as root of x squared minus 1. So this just simplifies to 1 over 1 plus, remember, this square will cancel the square root. So we have just x squared minus 1 multiplying x over x squared minus 1. And now 1 will cancel out to -1. So we have 1 out of s squared multiplying x out of s squared minus 1. So this x right here will cancel one of the x's here. So we have this. If you multiply the numerators, we just have 1. In the denominator, you have x squared minus 1. So combining both terms, when we differentiated this, we had 1 out of s square root of s squared minus 1. And when we did for this, we had this right here. So we have minus 1 out of the absolute of x squared minus 1. But note, our x is positive. X is greater than 1, which is positive. So it means basically what we have is the absolute of x over here is just x, and this is s squared minus 1. So clearly we can see that this is the same as this. So if we subtract it, we end up getting 0 as our final answer. I hope this is clear, and if there is any question, just let me know. So that is it for today's discussion on the derivatives of inverse trig functions. I hope this video helped you see how these derivatives work and how they fit into the broader picture of calculus. If you enjoyed learning with me, don't forget to like and subscribe for more content in this Calculus 1 series. Drop any questions or feedback in the comments. I would love to hear from you. Thanks for watching, and I'll see you in the next video. Bye.